Looking at probability today. So there's a couple of things we need to know before we look at the examples that you have. First thing that we need to know is how would we do this? So when you're trying to find probability, you're always going to do the number that you have of what you want. So if I wanted blue marbles, you're going to count how many blue marbles do you have and then put it over the total of things that we have. So if there was 10 total marbles, you would put 10 on the bottom. This is a couple of vocabulary words that we need to know. The first vocabulary word is compound events. Compound events are when one thing happens after the other. And there's two different kinds of events. One can be independent. It could also be dependent. Now, what does that mean? If you hear the word independent, that's an event that doesn't affect one another. So what I do the first time will not affect what I do the second time. In a dependent event, they do affect one another. I did something the first time. Maybe I took out a marble and I'm keeping it. So that's going to affect the second time that I want to reach in and get a marble. It's going to affect that probability. So these are some vocabulary words that we really need to make sure we understand. Here's an example. It's not part of your notes. It's just to kind of clarify some things. If I have 5 blue, 2 yellow, and 1 red marble, and they ask me to find, this is how you will see it written, P of B. All that means is to find the probability of getting a blue. So to find the probability of getting a blue, I'm going to count how many do I have of what I want. In this case, I want blue marbles. So I have 5 blue. I'm going to put that on the top. That's what I have of what I want. And then how many total marbles do I have? I have 5 blue, 2 yellow, and 1 red. So that makes a total of 8 marbles. Therefore, the probability of me reaching in that bag and getting out a blue marble is 5 out of 8. In your notes, we have an example 1, and it says that a box has equal number of green, orange, and blue marbles. And they want to know if you drew one out and then replace it and get another one out, what's the probability of getting a blue marble and a blue marble? Well, let's take a look. If I want to get a blue marble, I have equal amounts. Therefore, I have a third, and a third. So the fraction of blue marbles is 1/3. Since I'm not keeping it, I'm putting it back into the bag. Those two things aren't affecting each other. In a dependent event, if I kept that blue marble, that would affect the outcome of the second time that I go in there because I've reduced the number of total marbles. Here it says I return it. So these don't affect each other. I just can do the one event and then the other event. So 1 out of 3. And the second time it would be the same. It'd be 1 out of 3. Now what do I do with those two fractions? When we have compound events, one is happening after the other. To find the total probability of two events happening, I multiply the probability of each event. So I would be doing 1/3 times 1/3, and that gives me 1/9. In example 2, they say that you're going to select a card from some words, from letters A, E, I, O, U, P, and C. The first time you reach in and you got an E. Now you're going to, it says that you don't replace it, so you keep it in your hand. And they want to know if I get another one, what would be the probability of getting something that's not a vowel? Well, right now we don't have E anymore. Right now, we only have A, I, O, U, P, and C. So that's a total of 6 words. 6 letters, I'm sorry. We have 6 letters. And what are ones that are not vowels? Well, P is not a vowel. C is not a vowel. And that's it. So how much do I have of what I want? Well, not vowels is 2. How many total do I have now that I got rid of that E? I have 1, 2, 3, 4, 5, 6 total. So the probability of me getting a card that's not a vowel after I have taken out an E is 2 out of 6. If I simplify this, 2 over 6 is actually reduced to 1/3. In example 3, they gave us a little chart of the possible outcomes of tossing 2 coins. We can get heads, 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 tails, tails, heads, or tails, tails. And they want to know what's the probability of me getting tails, tails. In this case, since you already drew out all the different outcomes, we just need to circle what's the one outcome that I want. I want to get tails, tails. So that only happens one time. Out of how many possible outcomes? We have 4 possible outcomes. So the probability of me getting tails, tails would be 1/4. This is our last example. They gave us a little web, train, bus, cars, and the different places you can go. You can go west or northwest. So there's a total of 6 possible outcomes. And they want to know what's the probability of me taking the bus and going west. So I circle. How many outcomes is that? That's only one outcome where that would happen. Therefore, it would be 1 out of how many possible outcomes? I have 6 possible outcomes. So the probability of me taking the bus and it going west would be 1/6. Now this is doing a web. What if we just focused on the probability of each one? The probability of me getting a bus, since there's 3 different ways I can get there, is 1 out of 3. The probability of me going west, I have west or northwest. Those are my 2 options. So that is 1/2. And what do I do with those 2? I multiply. So 1 times 1 is 1, and 3 times 2 is 6. So if you realize we just learned 2 different ways of finding it. We can do our different possible outcomes and choose the correct one, or I can find the probability of one, the probability of the other, multiply, and I have now found my probability of both events happening.